Diazonium salts have the general formula Rn2X, where R is an aryl group. The counter ion X- may be a chloride, bromide, or hydrogen sulfate, or a tetrafluoroborate ion. The diazonium group consists of two nitrogen atoms, triply bonded to each other with an overall +1 charge. Aryl diazonium salts are used as intermediates to synthesize a wide variety of organic compounds. To name diazonium salts, add the word diazonium to the name of the parent hydrocarbon. This is followed by the anion name. Consider the compound shown here. There is a diazonium group plus an ethyl group at position 4 on the benzene ring with the chloride anion. The correct name of this compound is para-ethyl benzene diazonium chloride. Can you name this aryl diazonium salt? Notice that there is a fluorine substituent at position 3 of the ring, or the meta position with the hydrogen sulfate anion. This compound is named metafluorobenzene diazonium hydrogen sulfate. Primary alkyl diazonium ions are not very stable. They decompose easily and tend to be explosive when dry. Aryl diazonium salts are stable only for short times at low temperatures. Resonance structures help to stabilize the ion by delocalizing the positive charge around the aromatic ring. To prepare aryl diazonium salts, aniline is reacted with nitrous acid at 273 to 278 Kelvin. The nitrous acid is generated in situ by the reaction of sodium nitrite with hydrochloric acid. The overall scheme is summarized here. Due to the low stability of the diazonium salt, it must be used immediately after preparation. To prepare benzene diazonium chloride in the lab, a solution of aniline is prepared in hydrochloric acid and placed in a beaker of ice. The sodium nitrite solution is also cooled on the ice. The solution of sodium nitrite is then added very slowly to the solution of aniline in hydrochloric acid, keeping the temperature below 5 degrees Celsius at all times. If you use a different acid, you will get a different anion for the salt. Benzene diazonium chloride is a colorless, crystalline solid. It dissolves readily in water It is stable in cold water but reacts with warm water. Benzene diazonium fluoroborate is insoluble in water. It is stable at room temperature. The reactions of aryl diazonium salts can be sorted into two classes. Many reactions of benzene diazonium salts involve the displacement of the diazonium group, as nitrogen is an excellent leaving group. Aryl diazonium ions can also undergo coupling reactions. Using the nitrogen atoms of the diazonium group to link to another aromatic ring. We first consider the reactions that involve the displacement of the diazonium group. The first group of reactions that we will discuss are known as the Sand-Meyer reactions. In these reactions, the diazonium group is replaced by a chloride, bromide, or cyanide ion in the presence of copper-1 ions. Nitrogen molecules are released as a byproduct of the Sand-Meyer reactions. Here is a problem for you to solve. Predict the major organic product of this reaction. The first step of the process converts 2-aminotoluene into the corresponding aryl diazonium salt. You should recognize the second step of the process as a Sand-Meyer reaction. Under these conditions, the diazonium group will be replaced by a nitrile group. In the Gattermann reactions, the diazonium group is replaced by a chlorine or bromine group. To carry out these transformations, the diazonium salt solution is treated with the appropriate halo acid in the presence of copper powder. In general, yields for the Gattermann reactions are lower than for the analogous Sand-Meyer reactions. Try to solve this problem on your own before checking the answer. Write equations showing the synthesis of this compound from an appropriate aniline derivative using the Gattermann reaction. With these types of problems, working backwards can be a very effective strategy. We need a bromine atom at position 4 on the aromatic ring. So we can carry out a Gattermann reaction using a diazonium group in the correct location. We can make the diazonium salt from the appropriate aniline derivative. Let's put it all together, working forwards from the aniline derivative that we need. We can convert the aniline derivative into a diazonium salt by treating it with nitrous acid. Subsequently, we can treat the diazonium salt solution with hydrobromic acid in the presence of copper powder to form the desired product. The diazonium group can be replaced by iodine ions if the diazonium salt solution is treated with potassium iodide. This reaction forms iodobenzene as the primary organic product. Try to answer this question on your own before proceeding. Draw the major organic product of this reaction. You should recognize the steps involved. Step 1 produces an aryl diazonium ion. In step 2, treatment with potassium iodide replaces the diazonium ion with iodine. The Schumann reaction is a method for making aryl fluorides. In the first step, a primary aryl diazonium salt is treated with fluoroboric acid to make an aryl diazonium fluoroborate, which precipitates. Next, the dry diazonium fluoroborate is heated until it decomposes, releasing an aryl fluoride. Can you give the structure of the expected product for this reaction? You should recognize this as the Schumann reaction. The amine group will be transformed into diazonium group and ultimately be replaced by fluorine. Reductive deamination of primary aryl amines replaces the amino substituent by hydrogen using a diazonium salt as an intermediate. When the diazonium salt is treated with a mild reducing agent such as hypophosphorus acid, sometimes known as phosphenic acid, the diazonium ion is reduced to an arene. Alternatively, this can be carried out using ethanol. Can you complete this reaction? In the first step, the corresponding diazonium salt is prepared. Next, the diazonium group is replaced with a hydrogen atom. Nitration reactions replace the diazonium group by a nitro group. First, prepare diazonium fluoroborate by reacting the aryl diazonium chloride with fluoroboric acid. When the diazonium fluoroborate is heated with aqueous sodium nitrite in the presence of copper, the diazonium group is replaced by a nitro group. Phenols are readily produced from diazonium salts. These reactions cause the diazonium group to be replaced by a hydroxyl group. To carry out these reactions, acidify an aqueous solution of the diazonium salt by adding sulfuric acid at 100 degrees Celsius and heating it. Azo-coupling reactions are electrophilic substitution reactions that take place when a diazonium salt is reacted with a phenol or aniline derivative. In these reactions, the diazonium cation acts as an electrophile, while the electron-rich compounds such as phenols and amines act as nucleophiles. The aromatic rings are joined via the nitrogen atoms. The azo products of the coupling reactions have extended conjugation involving both the aromatic rings. As a result, the products are highly colored. They are often used as dyes. For example, para-hydroxyazobenzene is an orange dye. Para-aminoazobenzene is a yellow dye. As we have seen, diazonium salts are very good intermediates for introducing a variety of functional groups onto an aromatic ring. They allow for substitution patterns that cannot be prepared by direct substitution of benzene or substituted benzenes.